Hi everyone. Today we'll be going into the second question in Ionic Equilibrium. So this is a rather common type of question and it has on the concept of ionic product of water, Kw, as well as Le Chatelier's principle in chemical equilibrium. So let's go into the question. The value of the ionic product of water, Kw, varies with temperature.
What can be deduced from this information? Let's look at statement A first. Molar concentration of H plus ions decreases with decreasing temperature. So what we have here at 25 degrees Celsius, we have the ionic product of water. Ionic dissociation of water occurs when one molecule of water dissociates to give you 1 mole of H plus ions and 1 mole of OH minus ions. So over here, Kw, which is a kind of equilibrium constant, is equivalent to the concentration of H plus times the concentration of OH minus. So over here, at 25 degrees Celsius, what is the concentration of H plus ions there? So over here, the Kw is 1 times 10 power negative 14, which is equivalent to concentration of H plus times concentration of OH minus. Now, since I have 1 mole of H plus as well as 1 mole of OH minus, this means that my concentration of H plus is equivalent to my concentration of OH minus after dissociation. So hence, I can just write it as concentration of H plus squared. Since my concentration of H plus is equivalent to concentration of OH minus, because 1 mole of H plus and 1 mole of OH minus is produced. Okay, so that would mean that concentration of H plus ions is equivalent to the square root of 1 times 10 power negative 14, which will give you 1 times 10 to the power negative 7. What about at 10 degrees Celsius? At 10 degrees Celsius, the Kw is equivalent to 0.3 times 10 power negative 14. And this is equivalent to concentration of H plus squared. Because like we were saying, concentration of H plus is equivalent to the concentration of OH minus. Therefore, I can write it as concentration of H plus squared. So therefore, concentration of H plus will be square root 0.3 times 10 power negative 14. And therefore, it will give me an answer of 5.4772 times 10 power negative. So over here, as the temperature decreased from 25 degrees Celsius to 10 degrees Celsius, you notice that the concentration of H plus also decreased. Okay, so therefore A is correct. Then let's look at B. The ionic dissociation of water decreases by a factor of 10 between 0 and 25 degrees Celsius. So let's take a look at the table. From 10 to 25 degrees Celsius, there is an increase in temperature and the Kw value increased by a factor of 10. So therefore, this is wrong. It should have been increased. Next, C. The dissociation of water molecules by hydrogen bonding increases as temperature increases. So over here, let us take a look at the equation of the auto-ionization of water again. So in order to know what happens when temperature increases, we have to look at whether this reaction is endothermic or exothermic. Okay, so this is where it is linked to Le Chatelier's principle of chemical equilibrium. So over here, I have a water molecule. How does it dissociate to become H plus and OH minus? Well, we have to break the OH bond, right? So therefore, bond breaking is involved. Only bond breaking, there's no bond forming here. And bond breaking, in order to break the bond, you will need to gain energy to break a bond. Hence, the enthalpy change is endothermic for the forward reaction, which is the dissociation of water molecule into its ions. Okay, so now, based on what we have learned in Chatellier's principle, when temperature increases, so let me change the color. When temperature increases, endo reaction is favored. Why is endothermic reaction favored? Because when the temperature increases, the system will want to shift such that it can return it back to equilibrium. So therefore, it will favor the endothermic reaction, which can absorb excess heat. Okay, so therefore, it will favor the endothermic reaction. And in this reaction, the forward reaction is endothermic. Therefore, the POE will shift, point of equilibrium shifts to the right. Hence, what do you see? If it shifts to the right, there will be more dissociation of water molecules into its ions, correct? So over here, let us read this statement again. The association of water molecules by hydrogen bonding increases. So what does this phrase mean? Well, in order for association of water molecules by hydrogen bonding to increase, it means that there's more water molecules. Because only when it exists as molecules, then you can have hydrogen bonding, right? So therefore, this is wrong. Because as temperature increases, there's more dissociation of H2O. Therefore, there should be less water molecules and more of H plus and OH minus ions. So therefore, over here, this concept is wrong. Then next, lastly, part D. Water is no longer a neutral liquid at temperatures below 25 degrees Celsius. Okay, so for this, let us make use of the working that we have done for part A. Okay, so over here, let's figure out the pH at 25 degrees Celsius first. So at 25 degrees Celsius, to get pH is negative log concentration of H plus, which is 1 times 10 power negative 7. Therefore, I'll have a pH of 7. And then let's take a look at the pH of the entire pH scale, meaning what is the maximum pH. So that will be negative log Kw, which is 1 times 10 power negative 14, which gives us 14. So this helps us to put things into perspective. So meaning the pH scale runs from 0 to 14. Agree? And then in the middle will be the point where the concentration of H plus is equivalent to the concentration of OH minus. Okay, and this is where you have pH 7. Because it's 14 divided by 2, the midpoint is 7. And this is the point where, since concentration of H plus is equivalent to concentration of OH minus, and it's neutral. So yep, water is neutral at pH 7 at 25 degrees Celsius. So now let us look at 10 degrees Celsius. What is the pH? So pH equals to negative log concentration of H plus, which is 5.4772 times 10 power negative 8, which gives us a value of 7.26. Then let us take a look at what is the pH of the maximum pH of the entire pH scale. So that would be negative log Kw. So that would be 0.3 times 10 power negative 14. And that will give us an answer of 14.523. So over here, let us put things into perspective on the pH scale. So this means pH scale runs from 0 to 14.523. So notice, it's no longer from 0 to 14. It's from 0 to 14.523. So let's look at the midpoint. The midpoint will be 14.523 divided by 2, which will give us 7.26. So what does this mean? This means that at the midpoint, when pH is 7.26, the concentration of H plus is equivalent to the concentration of OH minus. So therefore, the neutral point at 10 degrees Celsius is when pH is 7.26. Hence, water is still neutral at 7.26 at 10 degrees Celsius. Hence, this statement stating that water is no longer a neutral liquid at temperatures below 25 degrees Celsius is wrong. So therefore, the answer will be A. So in general, take note that water will always be neutral. Even though at different temperatures, the pH might not be 7, but it will always be neutral because it will always be the midpoint of the pH scale. Okay, that's all for today. Hope that you all have understood this. Thank you so much for watching, and again, please follow us on Facebook, YouTube, and Instagram, and be updated with our daily questions and solutions. Thank you, everyone.